So in this video, we're going to continue topic 3.3, solving absolute value inequalities graphically. So you can use a graph to solve an absolute value inequality of the form f of x is greater than g of x, or f of x is less than g of x, where f of x is an absolute value function and g of x is a constant function. Graph each function separately on the same coordinate plane and determine the intervals on the x-axis where one graph lies above or below the other. For f of x greater than g of x, you want to find the x values for which the graph of f is above the graph of g of x. For f of x less than g of x, you want to find the x values for which the graph of f of x is below the graph of g of x. So when we get a little further, we're going to come back to those statements right there. So we're going to basically do the graphing like we did a few lessons ago. So I'm going to start by finding my vertex for this half of the graph here. I know that when we come in or out of parentheses or absolute values, I change my sign, and then I keep my outside sign the same. So I know I'm going to plot out -3 and up 1, and I did adjust this because we kind of fall off the graph patch. So if you want to pause and adjust the axes on your graph, that might be a good idea. And then I notice out front my slope is 1, so I'm going to plot up 1 over 1. I'm going to do that a couple of times, and I'm kind of going to imagine it here on this one. And then I'm going to go ahead and draw the V, and I'm being overemphasizing it on purpose here. Then we've got this half of the equation is just y equals 4. So I've got to draw a horizontal line at y equals 4. Now, let's go back to this statement. This was technically the f, and this was the g. So I have this first sentence. For f greater than g of x, you want to find the x values for which the graph of f is above the graph of g of x. So I want to be above the g of x graph, which is this line here, but I have to be below the f of x graph. So that's going to be this section right in here would be the values. And remember, up here we talked about value, that it only had certain values that actually worked. So this would be kind of like more like this situation where these just the top values worked there. So what we would say is if we picked any point that was within here, it would actually be a solution to this inequality. Whereas if I picked any point anywhere else, it would not be a solution to that inequality. All right, let's look at B. So they have, I should have probably taken out all of that stuff. I didn't delete it for you. They did some more solving with it than what we're going to do. We're just going to go ahead and plot it. So we're going to kind of ignore this piece right in here. So I'm going to start with my vertex. My vertex, I'm going to switch the sign, which would be 2, and I'm going to keep the sign, which is -3. So we're going to go out 2 and up 3. Notice how your graph is scaled. They did some, well, they didn't, it's scaled in ones, but they only marked every 2. And then again, we're going to do a slope of 1. So I'm going to go up 1 over 1. And I plotted the wrong direction, didn't I? Let me try that again. So we're going to do out 2, down 3 would be better. And I keep counting that slope up on both sides here. Which I don't have to do that. I'm just trying to be accurate with my graph right now. All right, and then I know this other side of the line is y equals 1. So I'm going to go to 1 and I'm going to draw a horizontal line. This time we had a less than symbol. So the less than symbol, let's read this sentence up here again. For f of x less than g of x, you want to find the x values for which the graph of f of x is below the graph of g of x. So we have to be below g of x, but above f of x. So that's going to be all these values in here. So what that means is if I pick any number in here, it would be a solution. It would be true. If I picked any other number anywhere else, it would be false and it would not be included in this.